Alright, today we're going to do experiment 8, which is percent silver in an alloy. We're going to isolate the silver and then we're going to synthesize silver chloride from that silver. So the first thing we're going to do is we're going to take our silver alloy and we're going to add nitric acid. Now nitric acid is going to dissolve all of the metals in the alloy, including the silver. Alright, and so the silver that is in the alloy is going to react with the nitric acid and it's going to form our silver ion and NO. Now the NO will react with oxygen in air to form NO2, which is a brown gas. This had to be done in the hood, so I did that previously, and then I'm going to show you the results that I got from that. Alright, and what we're going to do to form our silver chloride is we're going to take our Ag+, alright, so that's the ion, okay, but since I dissolved it in nitric acid, it is AgNO3 as an ionic compound, and I'm going to react that with HCl and do the classic double replacement reaction where you get your silver chloride. It is a white precipitate. And you get nitric acid, and then you will note that the alloy is going to have many other metals in it, but the HCl will only precipitate group 1 metals. Alright, so the group 1 metal ions include the silver ion, the mercurous ion, which is a diatomic ion, and the lead +2 ion. Alright, and so to be clear, that the alloy that is used in this lab is lead and mercury free. Alright, and so the only precipitate we're going to get when we add our HCl is the silver chloride precipitate. Alright, so I said that I had started this already. Alright, and I will show you where we're at. So I took and I made another coil. Alright, and so the first thing I did was I took our unknown. And so an unknown alloy is just an alloy that you would use for some sort of welding. Alright, it's going to be some silver alloy. And then it says to make a copper coil, and so I made a copper coil. So this is done usually near Christmas time. And so we're going to make our silver Christmas tree, is what I would normally say. Alright, so then you dissolved your alloy, and then you added some, okay, you dissolved it in the nitric acid. Alright, and so then it turned a blue solution, which indicates it probably has some copper in it. Alright, and then we added a little bit of 3 molar sulfuric acid. And then we added some deionized water, and then we put in our copper coil. And we are making our silver Christmas trees. So I'm going to turn this. This has been going for about 40 minutes or so. Alright, and so this is the silver that is precipitating on the copper metal. And so this is a single replacement reaction, where the silver is now collecting on the copper and the copper is going into solution. And so the copper going into the solution is making this solution get to be more of a bluish color. Alright, and so again I will move it around a little bit. So that is the silver that is growing on that copper metal. Alright, so now we're going to do some qualitative test. And so in our spot plates, all right, okay, so you have your report sheet, and I'm just following the report sheet. So this is in 1, 2, 3, 4, and 5 as you go across the top, and that's 1, 2, 3, 4, and 5, and you can see where there is copper nitrate that is a blue solution. Alright, and so we are to make our observations when we add 1 drop of hydrochloric acid. So this is 6 molar hydrochloric acid going into the first one. which is our AgNO3. Hopefully this shows up. All right, so I'm not sure if you can see that white precipitate that has formed, but you have a white precipitate now inside of there. All right, and so that is the observations that you're going to have for that. And when we put it into the copper solution, 1 drop of HCl, nothing visibly noticeable. All right, and to the zinc nitrate, again, nothing noticeable. All right, and now into the silver with 1 drop of copper nitrate. All right, so again, you should see the white precipitate that formed when that hit that solution. And then the last one is copper nitrate with 1 drop of silver nitrate. And let's see if we can see anything happening in here. Again, you do see some precipitate. It is not a lot of precipitate, probably hard to see in this video. But you got a little bit. It is cloudy. It is much cloudier. If you see the 2 blue solutions, you have the clear solution that is pure copper nitrate, and then you have the cloudy copper nitrate with 1 drop of silver nitrate. All right, so now we have the same 5 solutions down here, but this time we're going to add ammonium hydroxide. And I always tell people, if you get tired when you do the lab, take a whiff of this, wake you right up. All right, so we're going to add ammonium hydroxide to our silver nitrate in. All right, and so you have a formation of a precipitate, sort of. It's more of a cloudy. It turned cloudy. Interesting what's going on there. All right, and then you stick it into the copper. And you get a precipitate in that one, a bluish precipitate. Add a little more. Full drop didn't come out. There we go. So you have a darker blue formation. This is forming a copper complex ion. All right, and then when you put it into the zinc, you got some white precipitate forming there as well, with the silver and the 1 drop of copper. Again, you get that cloudy white reaction going on. And then again here you get that dark blue color that forms when you add it to the copper nitrate along with 1 drop of silver nitrate. And then we can add some more to our copper and see that it is turning a darker blue. Very colorful complex ion formation. And then the zinc is forming a white cloudy precipitate. And then the silver is also forming a white precipitate. All right, so that is it says to do it in a test tube. We did it in a spot plate. All right, so you have your observations for that chart. I'm not sure if it's easier to see with a black background. Maybe it is. So you have your precipitates. This is with the ammonium hydroxides. All of them have a precipitate in them. And then with your HCl, you have a precipitate in the first one. The next 2 are clear, no reaction going on with those 2, no visible reaction going on. And then you have your precipitates in the last 2. So I think it's easier to see it with a black background. All right, so the mass of the alloy was 0.7878 grams. So that was the mass of the unknown alloy that was dissolved. And then I weighed an evaporating dish. So here's our evaporating dish ready to be filled with our silver. All right, and that evaporating dish weighed 40.7142 grams. All right, so now we are going to take a bit of our solution out and test it to see if there is any silver that is left in the solution. So to test this, I will bring over our spot plate. I am going to take solution out. And I'm going to put it into a well here. Then I'm going to get, if there's silver in there, when it reacts with the HCl, it is going to form a white precipitate. All right, and so there is a small amount of precipitate being formed, which indicates that not all of our silver has been precipitated onto our copper coil. And the reaction is probably going slower because it is coated with the silver. So I will knock the silver. All right, and so now the silver is all at the bottom of our flask, our beaker. All right, and so that is, now it's going to keep reacting with the exposed copper. And I will test it. It looked like there was a very small amount of silver left. So we will probably continue with our experiment, even though we know that there's going to be a small amount of silver that is still in the solution. But we are definitely not out of copper. There is plenty of copper there, copper coil, that will take the silver out of the solution. All right, so what we're going to do now is we're going to get our silver out of this beaker and put it into our evaporating dish. And then we will, after we have cleaned our silver and then dried our silver, we will weigh the silver, and that will give us then our calculation for percent silver. So I will put the video down. All right, there we are. Hopefully we can see everything. And then we're going to clean our silver. So I will try to show you how you will wash a solution. All right, so I have my deionized water in the squirt bottle here, and so I can squirt down my copper, and yeah, I can see that it is still reacting, but it is a very, very small amount of silver that will remain in this solution. And so we are going to have some error, as always, when we do our labs. All right, and so I have the copper coil. We still had plenty of copper left for that to precipitate. All right, and then I'm going to decant this. Decant again means I'm going to pour the liquid, and the solid will remain inside of the beaker. All right, so if I lose a little, I'm not that concerned with losing a little bit of the solid. So I'm not going to use the stirring rod to protect the solid from coming out. I'm just going to be careful about that. And so then I'm going to wash it with deionized water. And so I simply put in deionized water. And when you are making silver, you don't think that silver is going to look like this, but this is what our silver is going to look like. It's not the nice shiny coin metal that we get from this reaction. All right, and so I will let it set. The density of silver is a very high number, and so I'm going to let all of the silver settle, get all the impurities out. For percent silver is going to be a little off, but I want my purity of my silver to be nice and pure. So that was the first wash. All right, so we wash with deionized water, and then we are going to then add 5 mils of ammonium hydroxide. So our ammonium hydroxide, we will add that. Okay, so we have our ammonium hydroxide. All right, we're washing with that, and then we just decant that solution into this beaker as well. We got a bit of a floating problem. Again, we're going to lose some silver. I'm looking more for the purity than I am percentages right now, so I just want this to be a nice clean silver. Then back to deionized water. All right, then one last deionized water, and then we're going to transfer it into our evaporating dish. All right, so now we will get our spatula, and we are going to then transfer the silver. Now we want the solid to come out, and so we are trying to get the solid to come out with this water. So we will then evaporate out all of the excess water, and then we will weigh it to get our mass of silver. All right, so we're going to use a Bunsen burner to heat this. Bit. I don't want it to. All right, when you're adjusting the flame, you don't adjust it down here. That adjust down here will adjust the air. You adjust it at the controller on the bench top. So you always want to have an inner cone. It has to be blue, or you're going to be depositing copper on the bottom of your evaporating dish. All right, so initially we're going to heat gently. Turn it up a little bit. We don't really want it too high. We don't want it to boil and blow the silver off the top. All right, so we are okay, we transferred, and we're going to heat this until the silver is thoroughly dry, and then we're going to cool it, and then we're going to weigh it, and then by subtraction we will have our mass of silver. That silver came from the alloy, which weighed 0.7878 grams, and so simply part over whole times 100 will give us our percent silver in the alloy. All right, now once we have our silver, we're going to dissolve it. And to dissolve it, we're going to add nitric acid. So the same reaction that we started with to dissolve our silver alloy was to add nitric acid, and it would dissolve it. We are going to do the same thing, except we're doing it with pure silver, not with other metals in there. And so we are going to add nitric acid. We will dissolve all of our silver, and that'll be then silver nitrate. We're going to add HCl. We're going to get our precipitate like we saw in our spot plate. We now have the mass of silver. We will then dry our silver chloride. We will then weigh the silver chloride. And so we will then have our mass of silver chloride. So if you have the mass of silver and you have the mass of silver chloride, you will then have the mass of the chloride ion that is in the silver chloride. Conservation of mass. Your silver ion plus your chloride ion yields your silver chloride compound, so you have your mass of reactants equal your mass of products. And we know by the periodic table how to find the correct value. It's simply the molar mass. The molar mass of your silver plus the molar mass of your chlorine. All right, and so that's your total molar mass. We have the molar mass of silver. Silver divided by silver chloride times 100. That's going to give us our correct value for percent silver. You have the periodic table. You have your chloride ion. All right, so you know the molar mass of that. Molar mass of that divided by the molar mass of the silver chloride. Again, silver chloride contains only silver and only chloride. And so those two percentages must add up to 100%. So when it says what is the experimental value, that's what we're finding here. When it says what is the theoretical value, you find that from the masses on the periodic table. Let's see how we're doing. All right, we are boiling water still, so it's going to be a while to boil all the water out. And hopefully we don't see anything shooting out the top. I want it boiling. I don't want it spraying all over the place. Turn it down a little bit. Well, since I wasn't worried about losing the silver, it would have been a better idea to decant some of the water that I poured in there before heating it. It's just going to take longer to boil out all that water instead of just pouring it out. All right, so let's see. I'm going to put this back in here, and just for my own curiosity, I'm going to put the silver back in to our wash solution and see if any more, I'm just going to put it off to the side here to see if any more silver precipitates out. I might leave that overnight just to see if there's more silver that will come out of that solution. More. All right. Your reactions, there are reactions listed on the bottom of the page. Assuming you have the same page, I'm going to probably update this a bit. Your zinc reacted with the ammonium hydroxide. It formed a zinc ammonium complex. As written there, that's not something you would need to be able to predict, and so it is just given to you in this reaction. The copper with the NH3, we knew that that did something because we knew the zinc did something as well. You could see the precipitates forming, and these are complex ions that were forming. Your copper complex ion was a much darker blue. Again, that is not something that you would need to know how to do. The silver nitrate with HCl forming silver chloride, that is something that you would need to know. All right, let's see how we're doing with our boiling. Crank it up a little more. All right, it's getting pretty close. if you have a fast forward button, you may want to fast forward to this. It's going to take, I don't know, hopefully not too much longer. I keep cranking it up more and more. I don't want it to. All right. This gives you a feel of what it's like to be in lab. You have to wait until it evaporates. There's no fast forward if you're actually in the lab. All right. So it just takes a while to get this to evaporate completely. But once that evaporates, then we gotta wait for it to cool. And then after we wait for it to cool, we can weigh it, then dissolve it, and then we have to do our reactions. After we dissolve, we do the reaction with HCl, and then we'll need that mass as well, and then we are done. So it's getting much lower. Not very exciting, I would show you. It's just water boiling with silver on the bottom of this thing, so nothing exciting happening, just boiling water. So if you're watching this video and then you're going to come in and do it, decant the water out of your evaporating dish. It takes a lot of water to make sure you get the silver in. Once you've done that, it's easily to decant the water out of the evaporating dish without losing any silver, and then the small amount you might lose, it's insignificant. And that will save you 15 minutes of boiling water. But you'll still have to heat it to dryness, and that's about where we're at now, is heating it to dryness. It's got a very small amount of water now, and this is where it gets dangerous, where the water gets underneath the solid and pops it out of the flask. I don't want that to happen, so I'm going to turn it down even more. So this is about the volume we should have started with. A very small amount of water inside there, and then boil that out. This is where you have to be the most careful, though. That water gets underneath that solid, boils, and pushes that solid right out. And very difficult to turn it down low enough to boil it and not lose it. really gets low, that's when the popping really starts to be a problem. I can still hear it. All right. And finally, we have dry silver. Turn that off. I'll grab see where the tongs went to pick this up. All right, so I can show you, better not drop it. All right, I can show you that this is the silver, so not very attractive, but that is what the silver looks like. All right, and then once this has cooled, we will have the mass of the evaporating dish and the silver. Then we can, by subtraction, get our mass of silver, and then by division get our percent silver in the alloy. All right, so it'll take a couple of minutes for this to cool. And it's a pretty cold day for a summer day. And it's nice and cold in here. What is our temperature in here? Not that it matters, but temperature, yeah, about 18 degrees Celsius. Pretty cold. Still too hot. All right. All right, so we have our nitric acid ready to dissolve that silver. Once we get a mass of that, we're going to dissolve it. And then we have our HCl ready to add to that as well. So we will dissolve it in our nitric acid. That will make our silver nitrate, which all nitrates are soluble. So it's in solution, and then we're going to add our HCl and do our double replacement reaction, forming our silver chloride white precipitate. All right, so our mass, it is cool enough. The mass of evaporating dish in silver, 40.9776. 40.9776. All right, so now we're going to add our nitric acid. All right, let me show you what that looks like. All right, so at just without heat, your nitric acid with the silver, it may eventually react, but it will take a while. If it reacts ever, it probably would just evaporate the nitric acid out. All right, so it's going to take some heat for this, so let's go ahead and turn on our heat. Again, we don't want it too hot. right, so you can see that it is now reacting. Now, when the bubbles are coming out, that is NO. The NO reacts with oxygen and air to form that brown NO2, which is a poisonous gas, so I'm holding my breath now. All right, so that is dissolving the silver. So I can turn the heat off. All right, and so now we have a solution. All of the silver has dissolved. All right, so we will let that cool a little bit. All right, so then we're going to add three mils of HCl. And just like we did with our reaction before, hopefully you saw that nice white precipitate forming. So that is the silver chloride. All right, so it's like an egg yolk. So we're making an egg yolk here. It is formation of the silver chloride precipitate. All right, we're going to add a little bit of an excess of HCl. Make sure that all of the silver precipitates. All right. So now we have our egg yolk. I'll just add a couple more drops. So here's our 3 mils that it calls for, although I don't see any solid forming, so we are good. All right, and so now we just have to dry this and weigh it. So that is your silver chloride that we are going to now evaporate to dryness, and then we weigh that, and then we are done. We will have all of the data that is required for experiment 8. All right, let's back up again. You want to heat this gently. You don't want the whole egg yolk flying out, so you can build up a lot of the liquid underneath there, and then it boils and it's trapped by that solid, and then it all boils out all together and flops out on the table. We do not want that to happen. So it is boiling at a nice rate. You don't want it to boil too fast. All right, so again, we are boiling again. So you again have a fast forward button. So you can fast forward to it's now dry and we're weighing it. But again, this gives you what lab is really like. It's not just automatically dry and then there's your mass. You have to dry it, you have to do things carefully. So you shouldn't be fast forwarding, you should be watching. All right. To get the full lab experience. So the write-up for the report sheet is relatively simple. Your percent silver, you just take your mass of silver divided by your silver alloy. That's the part is the silver, the whole is silver alloy times 100. Make sure you're doing your sig figs correctly. Evaporating dish, we have that, evaporating dish and silver chloride. Once we have the evaporating dish and silver chloride, subtract out the evaporating dish, you have the mass of silver chloride. You already have silver, now you have silver chloride, and so you can get the percent silver that's in the silver chloride, because all of the silver is in the silver chloride. We made sure we had an excess of hydrochloric acid. The theoretical percent silver, that's what you use the periodic table to find. And then you find the percent error. All right, so again, this is a lab. There is going to be a percent error. It is not going to be perfect. All right, you'll have to do the molecular, ionic, and net ionic equations for the silver nitrate with HCl. Again, silver nitrate, all nitrates are soluble, so that breaks into Ag plus and NO3 minus. HCl is a strong acid, 100% ionized. That breaks into H plus and Cl minus. Then you form your AgCl. That's a solid. Solids stay together. You don't break solids apart. Aqueous will be apart unless it is a weak acid. Remember, all acids are aqueous. Only the strong acids break into their ions. And then the other is going to be nitric acid, again another strong acid that would break into H plus and NO3 minus. You're also going to have to do the oxidation reduction reaction. When we're adding nitric acid, the one we just saw, nitric acid with the silver, that is an oxidation reduction reaction, because you have your Ag plus, or Ag is going to Ag plus, so we're oxidizing the silver, and the nitrate is being reduced. It's going from a +5, NO3 minus is a +5 oxidation, to NO, which is a +2 oxidation. But then that +2 oxidation is oxidized in air when it reacts with the oxygen in the air into the nitrogen in a +4 oxidation. It is still boiling in there. All right, and so you have to label the oxidizing agent, reducing agent. In order to oxidize the silver, silver is metal. 0 is the oxidation of metals. Any element on the periodic table, oxidation number is 0. Any ion, the oxidation number is the charge of its ion. And so our Ag silver metal, 0, is going to Ag plus. So we are oxidizing the silver. In order to oxidize it, we have to add an oxidizing agent. So we added the nitric acid to oxidize the silver, and that's why the nitric acid is the oxidizing agent. Well, the nitric acid has then been reduced down to NO, and so then your Ag is the reducing agent. It was oxidized and it reduced the nitric acid. And so those are, you have an oxidation half reaction, that is the silver going to silver plus 1 electron, that is your oxidation half reaction. The Ag is the reducing agent. All right, and it is oxidized. The reactant of the oxidation half reaction, the reactant is the reducing agent. We are still boiling. All right, so the nitric acid, again, it is reduced. All right, and so that's the reduction half reaction. And so the reactant of the reduction half reaction is the oxidizing agent. Again, it is called this because I have silver. I want to oxidize it. What do I need to find? I need to find an oxidizing agent. Nitric acid is an oxidizing agent. It will oxidize my silver. That's why it is called the oxidizing agent. We are getting very close to dryness here. One more mass, and we can call it an experiment now. Oh, we gotta, after it's dry, we have to let it cool for a while. All right, it's getting down. Of course, you don't want to lose patience at this time and start cranking it up so it goes faster, and then you plop your egg yolk out. Yeah, we do not want to lose our product at this point, so we are just going to wait, although a little piece just came out. Anyway, you're not going to prevent all of that problem, but you will reduce it by having the heat turned down. Another way to do it is to put the evaporating dish, have a lid on the top to make sure anything is blocked from coming out. That will add another 30 minutes to your boiling because it condenses on the top of that evaporating dish lid, and so the amount of error for the very small amounts that will come out is not a problem. Again, we know we're going to have lab error, all right, and it's, I mean, and it's good to know how to calculate those errors, and we won't be doing that. All right, it's getting very close. Still making some noise, generating some steam, so we're going to give it a few more minutes. All right, I'm going to let that cool down and get a mass, and then we are done. Let's see. Grab this. Show you what it looks like inside here now. So it should be a white precipitate. Don't want to drop it. All right, so it's white precipitate. It's got some yellowing around it. All right, I didn't want to melt it. I don't want to heat it too much, but I want to make sure that it is dry. All right, so we will wait for that to cool off a bit, get a mass, and then we are done. All right, it is cool enough, and the mass of the evaporating dish and silver chloride is 41.0523. 41.0523. And that is the end of experiment 8.